A warm welcome to all of you in this module on ceramic matrix composites. So, as you are well aware that we are in the process of discussing the subject on processing of non-metals. We have already covered 5 modules in which we have discussed different aspects of non-metals. In our earlier modules or the initial modules of this course, that is module 1, we have seen that what is the importance of materials, engineering materials, and how they are manufactured, or what are the challenges in manufacturing of engineering materials of various classes and forms. Then we have seen different types of materials. We have seen glasses, we have seen polymers, and we have even seen polymer matrix composites. We have also discussed a module which is a prerequisite for this particular module, that is module on ceramics, in which we have taken different aspects of ceramics. We have seen what are the various types of ceramic materials, what are the structure and properties of ceramic materials, and how the ceramic powders are made, and what are the processes which are used to convert these powders into ceramic products, what are the various application areas of the ceramic products. So, that was one particular module which was module number 3, which has already been covered in this particular course. If you remember, in module number 4 we have seen what are the different types of polymers, thermosets and thermoplastics, and what are the structure and properties of polymers or the plastics. We have seen in our previous module or the last module what are the various types of composite materials, and specifically module 5 was focusing on the polymer matrix composites, and we have seen different types of processes which are used for processing of polymer matrix composites. We have understood the basic mechanism of various processes, that how a polymeric matrix composite is made, or how the raw material, if you remember, there is a matrix and a reinforcement. Today also we will see the same diagram and we will try to understand that what is the basic philosophy of ceramic matrix composites, and what is the matrix in a ceramic matrix composites, and what are the different types of reinforcements in the ceramic matrix composites. So, just taking reference to what we have already discussed in polymer matrix composites, we have seen that how a polymeric matrix is blended with the reinforcement, what are the various types of reinforcements which are used in polymer matrix composites, and we have also seen different processes which are used to blend these two constituents of the composite material together, that is the matrix and the reinforcement. So, all that we have covered in this particular course till now has been focused on different types of materials which have the non-metallic properties and the processing routes for converting these materials into a tangible product or into different types of tangible product. So, whenever we have discussed a particular process, our focus has been on the conversion process, that how the raw material can be converted using different forms of energy or different types into the final product. So, our focus has been on the process, our focus has been on the process capability, our focus has been on the advantages of that particular process. Also, we have highlighted that what are the disadvantages of a particular process, and finally, we have zeroed down on certain specific applications of that particular process or the products which have been processed by that particular process. So, with this background, we are going to start today another module, that is on ceramic matrix composite. So, this introduction is necessary because this relates to the broad course that we are covering, that is the processing of non-metals. So, basically the total course is on processing of non-metals, and different materials that has been the focus area in this particular course has been the glasses, the plastics and the ceramics. And for plastics we have already taken one course or one particular module on processing of polymer matrix composites, and this particular module, that is module number 6, is focusing on the ceramic matrix composites. And in our last module, that is module number 7, our focus would be on the secondary processing of different types of non-metallic materials, specifically focusing on the the materials which have non-metallic properties and the composites of these materials. So, we will be focusing on the secondary processing in terms of machining and joining of polymer matrix composites, and to some extent to the ceramic matrix composites. So, that is going to be our last module of this particular course. So, with this introduction, now I come to the beginning or the introduction of today's lecture, that is on ceramic matrix composite. So, what are ceramic materials, that we are just going to revise, because this particular things or this particular topic has already been covered in our module on ceramic materials, and we are going to revise today that what are the ceramics, or there may be audience which is only interested in this particular lecture. So, if for them just to have an introduction that what are the ceramic materials and what is the need, when already we have a ceramic material, already we have the technology to convert a ceramic basic constituent into a final product. So, we can use a ceramic raw material and we can convert it into a final product. Then what is the need to reinforce this ceramic material into a new engineering material, which we are calling as the ceramic matrix composite. So, already the technology is there, the science of ceramics is understood, the technology for converting the ceramics into tangible products is well known. Then why we are using this particular material, that we are calling as the ceramic matrix composite? So, there has to be some logic, there has to be some need, there has to be some requirement for the development of advanced materials such as ceramic matrix composites. So, there has to be certain specific application spectrum for which the ceramics by themselves are not suitable. They have to be reinforced by certain reinforcements, so that they are able to meet the needs and the requirements of that particular application. So, what are the limitations of the ceramics, that also we are going to cover in today's lecture, and then we will see that what are the processing challenges for ceramic matrix composites, because this particular module is focusing on the various processing techniques that are used for processing of ceramic matrix composite. So, with this introduction to today's lecture, let us now focus on the primary or the basic fundamentals of the ceramics. Now, first important thing is the comparison of the ceramics and the metals. So, on your screen you can see that there are few properties which are better in case of ceramics as compared to metals. So, you can have a feel the melting temperature of ceramics is higher than the metals. The hardness is also higher, as well as the Young's modulus. So, most of the ceramics will have high melting temperature, they will have high hardness, and they will have higher Young's modulus. So, when we have a material at hand which has high melting temperature, which has high hardness and higher Young's modulus, for those materials we need to have specific manufacturing processes or specific processing routes. Why? Because if we go to the primary manufacturing process or the primary forming process, which are the basic processes which are used for forming, maybe one of the process may be casting, because it gives a shape to the product. So, when the melting temperature is very high, it is difficult to melt the material. So, ceramics have high melting temperature, therefore, it is difficult to melt them, and when it is difficult to melt a particular material, it is difficult to be processed by the simple casting process. So, therefore, casting or molding, which we are using very frequently or widely for metals, as well as molding in case of plastics. So, casting in case of metals and molding in case of plastics is relevant, because both the materials have relatively lower melting points, but in case of ceramics we have a very high melting point. So, when melting points are higher than the metals, it is difficult to make them by casting process. Similarly, the hardness is very high. So, if you remember, in the basic classes of manufacturing, it is taught that if you have to machine a material, the hardness of the tool should be higher or greater than the hardness of the workpiece. So if we want to machine a ceramic material, the hardness of our cutting tool should be higher than the hardness of the ceramic. So we have a material in our hand which has very high melting temperature, which has considerably high hardness, which has higher Young's modulus as compared to the metals. Therefore, the processing technology or the processing techniques required for processing of ceramics would be different than those for metals because of these properties. Why I am focusing only on the processing? Because our focus area is processing. We are discussing the course on processing of non-metals, and these particular applications or these particular properties would certainly advocate some important applications for these materials, like these materials can be used for high temperature applications. So we will see that what are the various specific application areas of the ceramic material. So this is just a revision of the module which we have already covered, but it is important because it is going to lay a foundation for the discussions related to the manufacturing or processing of ceramic matrix composite. So there are few properties which are higher or better than metals. We should not say better, because in certain cases these properties may also prove to be a challenge in case of ceramics, so or prove to be a limitation in case of ceramics. So the melting temperature, hardness and Young's modulus in case of ceramics is higher as compared to metals, whereas the density, thermal conductivity, electrical conductivity in case of ceramics is lower as compared to metal. So they are, we can say, poor conductors of thermal conductivity, electrical conductivity, and they have lower density as compared to metals. So these particular properties of ceramics also advocate certain specific applications for ceramics. For example, ceramics can be used where lightweight is a important design criteria. Wherever we have to design a material, wherever we have to advocate the use of a material for lightweight applications, yes, we can certainly choose ceramics over metals because they have lower density as compared to metals. Moreover, where thermal insulation is required, where we want less thermal conductivity, there also we can advocate the use of ceramics. Also the electrical conductivity, therefore we see huge application spectrum of ceramics in electrical insulation industry or electrical insulation applications. So to summarize what is being presented in this particular slide, we are trying to compare the ceramics with the metals, and we have seen that the melting temperature, the hardness and the Young's modulus of ceramics is higher than the metals, and the density, thermal conductivity and electrical conductivity of ceramics is lower than that for metal. So these are some of the properties which we should always keep in mind when we are doing any discussion related to the ceramics. Now just to revise the basic definition of the ceramics, ceramics are generally compounds of metallic or non-metallic elements and other non-metals such as oxygen, nitrogen, carbon and boron. So basically why this particular section is being discussed or why this particular module is being discussed in our course, so here the word non-metal is coming 2 times. So ceramics are generally compounds of metallic or non-metallic elements and other non-metals such as oxygen, nitrogen, carbon and boron. So basically the ceramics are made, or these are compounds which are made up of certain elements which have non-metallic characteristics. And what is the difference between the metal and a non-metal, that we have already covered in our previous module. So we are not going to discuss those things in detail, but this particular definition gives a summary of what are the basic, we can say, constituents of the ceramics. Also we have seen the different types of ceramics and their application in our previous module. So what are the preferred areas of application where the ceramics are used? So we have certain thermal and structural applications where the important design guidelines are that the material that is used for those applications, the applications can be thermal applications or structural applications. So those applications advocate high temperature resistance. So where high temperature resistance is required, because we have already seen in the previous slide that the thermal conductivity of ceramics is lower as compared to that for metals. So where high temperature resistance is required, there we can advocate the use of ceramics. High hardness is required. For example, where wear is going to take place, high hardness may mitigate the effect of wear. So there also we can say that ceramics can be used. Also where chemical inertness is required. In the subsequent slides we will see that what are the specific advantages of using the ceramic materials, and there we will see that one of the important advantages of ceramics is that they have chemical inertness. So they do not react with many chemicals. So they can be used where chemical inertness is an important design criteria. So what are the important three application spectrums for ceramic materials? They can be used for high temperature resistance, they can be used where high hardness is a design criteria, as well as where the application requires chemical inertness. So we have certain preferred areas of applications for ceramic material. So certainly where ceramics are used, there ceramic matrix composites can also be advocated or can also be applied or used. Therefore we, before going to the ceramic matrix composites, we can just target on certain specific areas where these materials that we are going to study today are going to be applied. So these are some of the specific application areas for ceramics as well as their composites. As I have already told, now we are going to just see that what are the advantages of ceramics. Now from the previous discussion which we have undertaken in today's lecture, many things are very clear, because we have seen that what are the various applications where ceramic matrix composites or till today or maybe till now we can say ceramics can be used. So those applications are advocated because they have certain properties. So now we will just outline that what are the advantages of ceramics. So one of the important advantage is that they have excellent chemical corrosion resistance in a wide range of environments and temperatures. So what was the last point in the previous slide, that the ceramics can be used in those applications where chemical inertness is required. So same point is being emphasized again now, that is one of the important advantage of ceramics. So the important advantage is that they have excellent chemical and corrosion resistance, and that also under wide range of environments. So widely or most of the environments are not going to affect the ceramic material, and therefore they are used for applications which require chemical inertness. Also the temperature does not affect the structure or the properties of the ceramics. So therefore they are used for high temperature applications also. So one of the important advantage of ceramics is the chemical inertness. Second advantage is the optical transparency over a wide range of wavelengths from ultraviolet to infrared. So that also advocate the use of ceramics in various applications, that is the optical transparency, and that also over a wide range of wavelengths and ranging from ultraviolet to infrared. So again I am reading the point for you. The optical transparency over a wide range of wavelengths from ultraviolet to infrared. So the application spectrum is huge, ranging from the ultraviolet to infrared. The ceramics offer optical transparency. So there also, because of this property, ceramics have got certain specific applications. Also high hardness and resistance to wear, which I have already told that wherever wear is going to be a problem, we can use a ceramic component there because of its high hardness. So when the hardness is higher, the wear should be lower under ideal conditions, because this thing can be refuted or it can be challenged in certain other applications. But wherever the hardness is increased, we can say the wear should be less under normal conditions. So high hardness, high temperature resistance, resistance to wear, resistance to various type of corrosive environments. So these are some of the important advantages which are offered by the ceramic materials. And last, on your screen you can see it have unique electrical characteristics, which we have already seen in our slide where we have compared the ceramics with the metals. We have seen that the electrical, or we can say conductivity of ceramics is less as compared to the metals. So when the conductivity is less, they can be used for insulation purposes. So the ceramics can also be used for insulation purposes, and the advantage with ceramics is that they have unique electrical characteristics. Why? Because we have seen in our previous slide there are few properties in which the ceramics have higher as compared to the metals. Now just to give you a brief review of what we have discussed on that slide, again I am revising: hardness, Young's modulus, and the temperature resistance is, or the melting temperature is higher in case of ceramics as compared to metals. On the contrary, we have seen the electrical conductivity, the thermal conductivity and the density is lower for the ceramics as compared to metals. Once again, because this is important when we will go to the ceramic matrix composites, because we have to see that where the ceramic matrix composites can be used. So we should understand the basic properties of ceramics. So when we compare a ceramic with a metal, there are few properties which are higher in case of ceramics. So what are those properties? That is the melting point, the hardness and the Young's modulus. What is lower? The density in case of ceramics is lower, the electrical conductivity is lower and the thermal conductivity is lower. So ceramics or ceramic matrix composites can be used for electrical insulation as well as for thermal insulation. So therefore we see lot of ceramic products in electrical insulation industry. So these are some of the advantages, and these advantages advocate the use of ceramics in a large number of applications where electrical insulation or thermal insulation is required, where lightweight is required, or in certain cases where the hardness is more, we can use it for wear resistant applications also. So why I am emphasizing on this? Because now we are going to move into a different spectrum where we are going to address the limitations of the ceramics. So before going to the limitations, we should be very clear in our mind regarding the advantages of the ceramics, because the limitations of ceramics will lead to the development of a concept of a completely new class of material, new family of materials, which is the today's topic, or which is the topic of our discussion today. Now what are the problem areas related to ceramics? So if you have understood, I have revised also what are the advantages and how the ceramics compare with that of metals. That point we have already emphasized 2-3 times. So I think it is very clear that what are the advantages of the ceramics. Now every material has got certain disadvantages or certain limitations also. So ceramics have got certain limitations also. Now what are these limitations? Low fracture toughness or damage tolerance, and they are highly brittle. Now these are the two important, we can say, limitations of the ceramics. So with these important limitations can be overcome with the development of the concept of a composite material. So low fracture toughness and highly brittle behavior of the ceramic has to be addressed somehow. So these two important limitations have to be overcome. So this leads to the development of ceramic matrix composites, or the CMCs. In brief, we can call them as the CMCs. So we have seen that CMCs now, what is the mandate of development of ceramic matrix composite I have revised 2-3 times. Ceramics have got certain advantages vis-a-vis metals. We have compared that ceramics and metals. Now ceramics have got certain advantages. The advantages also we have seen, preferred areas of applications for ceramics also we have seen, but there are few limitations with the ceramics. Now limitations are also highlighted on your screen: low fracture toughness or damage tolerance, as well as they are highly brittle. Now we want to minimize these particular limitations which are mentioned on the screen. In order to minimize these limitations and take advantage of the advantages of ceramics, a new concept of composites is developed, and the composites with ceramic as the matrix material are called the ceramic matrix composites. So now we will see that what is the basic concept behind the development of the concept of ceramic matrix composites. Although this we have already seen that what is a matrix, what is a reinforcement in our previous module, in which we have seen the polymer matrix composites, but in context of ceramic matrix composites again we will see that the basic concept of ceramic matrix composites. So basically composite material consists of two important macro constituents, that is the matrix and the reinforcement. So the matrix can basically be of the polymer. We can have a polymer matrix composite, we can have a ceramic matrix composite, and we can have a metal matrix composite. Since our course is focusing on processing of non-metals, so our focus is on polymer matrix composite and ceramic matrix composite. Polymer matrix composites we have already covered in our previous module. This particular module would be focusing on the ceramic matrix composite. So basically a composite is made up of two macro constituents which are called the matrix and the reinforcement. These two are combined together to make a composite material, and in case of ceramic matrix composite, the matrix would be made up of any type of ceramics. The different types of ceramics we have already covered in our previous module, and we would be covering in this particular module also. But before going into the details of the types of the matrices which are used, or the ceramic matrices we can use for making a ceramic matrix composite, we need to understand the basic concept that in ceramic matrix composite the matrix would be made up of a ceramic material. A type of ceramic can be different types of ceramics are there, but the matrix would be ceramic, that is the bulk would be provided by the ceramic material. Then the reinforcement can further be divided into three categories. We can have a shape. On the basis of shape we can have different types of reinforcements. On the basis of orientation of the reinforcement we can have different types of composites. We can have aligned reinforcement, we can have a random type of reinforcement. So on the basis of the orientation the composites can be different, and on the basis of the chemical nature of the reinforcement we can have different types of composite. So reinforcement can further be subdivided into three subcategories on the basis of shape, on the basis of orientation, and on the basis of chemical nature. So one by one we can see. On your screen you can see on the basis of shape we can have continuous reinforcement, we can have short fibers reinforcement, we can have whiskers as a particular shape of the reinforcement, and we can have particulate type of reinforcement. So majorly in case of ceramic matrix composite, the reinforcement can be continuous reinforcement or it can be in the form of particulates or whiskers. So we can have different shape of the reinforcement that would go into a ceramic material. Depending upon the material of the reinforcement also we can have a ceramic as a reinforcing material also. So we have a ceramic as the matrix, we have a ceramic as the reinforcement, and we can have a ceramic composite material in which the matrix is also a ceramic material and the reinforcement is also a ceramic material. So the two ceramics are now combining together to make a composite material. Why we are combining the matrix and the reinforcement together? Because we want to take advantage of the ceramic material. We have already seen that the ceramics offer a lot of advantages as compared to the other engineering materials. So we want to take those advantages, but it has got certain limitations in terms of fracture toughness or damage tolerance, as well as the ceramics are brittle. So in order to overcome those limitations, we are adding a reinforcing phase, and we are developing a new material, or we are developing a new concept which is minimizing the limitations of the monolithic, or we can say only ceramic. If you use only ceramic, it has got certain limitation. We are reinforcing it with the reinforcement, the limitations are minimized. So on the basis of shape, we can have different types of reinforcement. We can have a continuous reinforcement, we can have short fiber reinforcement, we can have whiskers as the reinforcement, we can have particulates as the reinforcement. On the basis of orientation, I have already told, we can have all the reinforcing elements in one direction, we can have a aligned reinforcement or a directional reinforcement. The reinforcement can be randomly distributed in the matrix, there also we can have a random reinforcement. So we can have a aligned reinforcement, we can have a random type of reinforcement, and on the basis of the chemical nature, we can have oxides, for example aluminum oxide, we can have carbides such as silicon carbide, and we can have nitrides of certain elements. So basically the chemical, on the basis of the chemical nature of the reinforcement, we have got a wide variety of materials which can be used as the reinforcing materials in the ceramic matrix. So we can have oxides, carbides and nitrides as the reinforcing material in the ceramic matrix. So in order to summarize the ceramic matrix composites, we can have a matrix, we can have or we have a ceramic matrix which is reinforced with the additional reinforcement, and the reinforcement can be on the basis of shape, it can be continuous, short fiber, whiskers or particulate. On the basis of orientation, it can be aligned or it can be random. On the basis of chemical nature, we can have oxide, carbides or nitrides. The examples already I have given. So this is the basic concept of the ceramic matrix composite. Now ceramic matrix composite, from this concept we can come on to a very simple definition of the ceramic matrix composites. On your screen you can see the ceramic composites are the materials in which one or more ceramic materials are deliberately added to another in order to enhance or provide some property not possessed by the original materials. So original materials have got certain properties, but they have got certain limitations also. So in order to overcome those limitations, we add additional materials which may be ceramic, may not be ceramic, and we try to develop a concept of a material which aims at overcoming the limitations of the original or the basic material. So the definition also states that, only the basic summary of the definition is that the materials in which one or more ceramic materials are deliberately added in order to enhance or provide some property which is already not possessed by the original material. So this is a basic definition of ceramic matrix composite. So by now I think the audience might have got an idea that why we are trying to develop a new material when already we have got a science and technology, a well developed science and technology in case of ceramics. So all those ceramics, the science is known, what are the basic constituents in a ceramic is known, how the ceramics can be made into products is known. The why we are advocating the use of ceramic matrix composites, because of certain limitations of the ceramic, we are adding additional phase or additional material into the ceramic or the basic ceramic material in order to overcome those limitations which are present in the original materials. Now again, the introduction of the ceramic matrix composites, although it has been explained in detail with the help of a diagram that the matrix is a ceramic material, the reinforcement can be of different types on the basis of the shape of the reinforcement, on the basis of the chemical nature of the reinforcement, and on the basis of the orientation of the reinforcement, we can have different types of ceramic matrix composites. So all those things have now been highlighted in these points. So point by point we will address, and if the need is there, I will give certain examples also. So, in ceramic matrix composites, a given ceramic matrix is reinforced with either a discontinuous reinforcement such as particles, whiskers or chopped fibers, or with continuous fibers. So, if you see the diagram, or if you remember the diagram what we have discussed in a previous slides, the matrix is a ceramic material and the reinforcement on the basis of the shape can be of different types. It can be discontinuous type or it can be of continuous type. So, in continuous type we can have fibers, and in discontinuous type we can have particles, whiskers or short fibers or chopped fibers. So, on the basis of the shape of the reinforcement we can have different types of ceramic matrix composites. So, the primary aim of the reinforcement is to provide toughness to an otherwise brittle matrix. So, this particular point addresses the limitations of the ceramics. If you remember, what are the two important limitations of the ceramics which we have already seen in today's lecture? The two important limitations are the fracture toughness and the brittle behavior of the ceramics. So, the primary aim of the reinforcement is to provide toughness to an otherwise brittle matrix. So, the reinforcement addresses both the issues of the toughness and the brittleness. So, if we are adding a reinforcement which can be discontinuous or can be a continuous reinforcement. So, when we are adding the reinforcement, it is addressing both the issues of the toughness as well as of the brittleness. So, we can say that deliberately we are adding a reinforcement into the ceramic matrix in order to improve its properties and to do away with the limitations which are present in the monolithic material or in the original ceramic material. Fillers are also added to the matrix during processing to enhance the characteristics such as electrical conductivity, thermal conductivity, thermal expansion and hardness. So, what are fillers? So, basically we can say in any composite there are three constituents. One is the matrix which provides the bulk, another is the reinforcement which in our case we have seen it can be discontinuous or continuous reinforcement, we can have continuous fibers or chopped fibers, and the additional phase are the fillers. So, fillers are added in order to give specific requirements or in order to give specific properties to the composite material. So, we can see that what are the properties which can be enhanced with the addition of the fibers. So, we have seen that the electrical conductivity is poor as compared to metals in case of ceramics, electrical conductivity is poor in case of ceramics, thermal conductivity is also poor in case of ceramics, and the hardness is good. So, even if we want to further improve the hardness of a ceramic, we can add certain fillers. If we want that we should try to manipulate the thermal conductivity and the electrical conductivity of a ceramic material, we can add certain fillers into the composite material. So, basically we will have a ceramic matrix, we will have a reinforcement and we will have the fillers, and we will try to develop a concept of a ceramic matrix composite which would try to address to certain specific applications where the ceramics by themselves are not able to meet or they are not able to satisfy the requirements. So, basically the concept of ceramic matrix composites is being developed to overcome certain limitations of the monolithic ceramics. So, we can add certain fillers to further improve the properties of the ceramic matrix composites. Now, what are the different types of reinforcement? On the basis of the shape of the reinforcement, we can have different types of reinforcements. So, we have already seen that we can have continuous fibers in the reinforcement, we can have particles in the reinforcement, we can have whiskers in the reinforcement. So, different types of reinforcements can be added into the ceramic matrix. So, this is one particular example we can see. We can have fibers as the reinforcement, we can have whiskers as the reinforcement, and even layers can also be added as the reinforcing phase or the reinforcement material. But in this particular slide we are just going to see the particulate reinforcement. So on your screen you can see we can have spherical particles as the reinforcement, we can have irregular shape of reinforcement, we can have faceted type of reinforcement. You can see in this we have 4 faces. Here we have spherical, all the reinforcement particles, although the size of the particles is different, but the shape is spherical in all the cases. Whereas here we have irregular shape, somewhere we have this particular shape, this shape is different from the other shapes of the reinforcement. So the reinforcement we are putting in a ceramic matrix, it is in the form of a particulate or in the form of particles, and the particles can have different shapes. So on your screen you can see the particles are spherical particles, or there can be irregular particles, or they can have certain specific faces, or they can be called as faceted particles, and all this is called the particle morphology or particulate morphology. So this is one particular example of the how the reinforcement will go into the ceramic matrix. We can even have continuous fibers in the ceramic matrix, and the reinforcement in this particular case would be continuous fibers. So the generic name would be ceramic matrix composite only, but the reinforcement would be continuous in the form of fibers, as is case number 1 on your screen. So we can have continuous fibers also as the reinforcement, we can have whiskers also as the reinforcement, we can have different layers also as the reinforcement, but this particular slide gives an idea that how the particles can be added as a reinforcement. So we can just say that this white background represents the basic ceramic material, and these grey spherical particles represents the reinforcement which has been added into the basic ceramic matrix. So white portion represents the matrix, white portion represents the matrix, and the grey portion represents the reinforcement in case of the ceramic matrix composite. Now why we should use a ceramic matrix composites when already the ceramics are available with us? So the important applications are where we require excellent wear and corrosion resistance. So ceramic matrix composites are widely used for wear resistant properties and the corrosion resistant properties. Wherever we want lightweight applications, higher strength to weight ratio is one property which advocate the use of a material which has high strength to weight ratio for lightweight applications. As we have already seen in our comparison of the ceramics and metals in the beginning of today's lecture, we have seen that the density of ceramics is lesser as compared to that for metals. So therefore the ceramic matrix composites can also be advocated in those applications where lightweight is the requirement. So they can be used for excellent wear and corrosion resistant properties, they can be used for high strength to weight ratio where lightweight applications are there, high strength retention at elevated temperature. So if you remember from the basic manufacturing processes, one of the important properties of the cutting tool material is the hot hardness. So what is hot hardness? Hot hardness means that the cutting tool should retain its hardness at the elevated temperature. So elevated temperature is the temperature in wherever the tool is in contact with the workpiece. So at that particular zone the tool should retain its hardness at elevated temperature. So therefore ceramics or the ceramic matrix composites are the material which retain their hardness even at elevated temperature. So they retain their strength and hardness, although in this particular point it is written that higher strength retention at elevated temperature. So which means that they should be able to retain their strength at higher temperature. So one of the advantages of ceramics as compared to that for metals was that they have higher melting points. So this particular property boils down from that particular property of the ceramics. So one of the important advantages is that they can retain their strength at higher or elevated temperature. And moreover, ceramic matrix composites have very high hardness. So why should we use the ceramic matrix composites? So there are 4 important, we can say, catch points or key points that we should keep in mind. So first important catch point is the excellent wear and corrosion resistance. This property is coming from directly from the ceramics. If you remember, we have today revised 2-3 times the basic properties of the ceramics, and we have seen that they have very high hardness, wear resistance is good, as well as chemically they are inert. So when they are chemically inert, the basic material or the basic ceramic is chemically inert. The composite that we are going to make with that particular material as the ceramic ought to be chemically inert. So therefore it will be resistance to corrosion, it would be chemically inert. The wear resistance would be good, strength to weight ratio is higher, which means it can be used for lightweight applications, high strength retention at elevated temperatures, and high hardness. So again I have revised the salient advantages or the salient properties that the ceramic matrix composites possess, or the important characteristics of the ceramic matrix composites. So these are the important points we should always remember in context of the ceramic matrix composites, because these will further advocate or these will further lead to specific applications of ceramic matrix composite. So when we know the characteristics or the important advantages of a particular material, we can definitely advocate the use of that particular material in certain specific applications. So wherever lightweight is required, wear resistance is required, resistance to corrosion or chemical inertness is required, and high hardness is required, we can very easily advocate the use of the ceramic matrix composites. So we have seen 4 important characteristics, then these are another which are boiling down from those characteristics only. So those were highlighted, the characteristics like high strength to weight ratio, which means used for lightweight applications, resistance or high corrosive resistance, which means high chemical stability, and non-catastrophic failure. So non-catastrophic failure means that they will take some load and they will have some deformation before the actual catastrophic failure takes place. So the stress strain behavior is of a monolithic ceramic is different from the stress strain behavior shown by the ceramic matrix composites. Why? Because of the presence of the reinforcement or the additional reinforcement in the matrix. So the monolithic ceramic or simple ceramic will have a catastrophic failure, whereas a ceramic matrix composite will not have a catastrophic failure, it will certainly undergo some strain before it finally fails. So if we see the stress strain curve, if possible in the next particular lecture we will see the stress strain curve of a monolithic ceramic and for that of a ceramic matrix composite. So this would be different, therefore the ceramic matrix composite will show a non-catastrophic failure, whereas a ceramic material, because it is highly brittle, will show a catastrophic failure. So therefore ceramic matrix composites have some synergic properties of the two phases which have been combined together, and they possess certain specific advantages as compared to those of ceramics. So therefore from the very beginning we have seen why do we need to develop a concept of a ceramic matrix composite. We started our discussion of CMCs from the point where we ended up with the limitations of the ceramics. So wherever the limitations are there on account of fracture toughness or damage tolerance, and because of highly brittle nature of the ceramics there are certain limitations. So those limitations are overcome by the concept of the ceramic matrix composites. Now what are the various processing techniques that we are going to cover in our module of ceramics? or ceramic matrix composites. So these are some of the important processing techniques, that is the powder metallurgy. In powder metallurgy we will see the sintering or hot isostatic pressing. So we will see what are the basic process details of powder metallurgy, what are the different types of powders that can be used and how these powders can be converted into the tangible products, what are the products that can be made out of the powder metallurgy technique. We will see the infiltration process, what is the basic process detail of the infiltration process, what are the specific application areas of the products made by the infiltration process, and also we will see the deposition processes such as spraying. So these are some of the processing techniques which are used for processing of ceramic matrix composites, which we would be covering in this particular module on ceramic matrix composite. So broadly the processes can be divided into three categories, that is the powder metallurgy technique or the powder metallurgy route, infiltration process and the deposition process. So these are the three broad categories of processes which are used for processing of ceramic matrix composites. And once the product is ready, it is post processed. So the processing of ceramic composites is done. Why post processing is required? Sometimes we want to have a specific surface finish requirement, so therefore grinding can be done. Sometimes some functionality has to be added into the product. All of you might have heard the self lubricating bearings. So in case of self lubricating bearings, sometimes lubrication has to be additional function which has to be provided, or the product has to possess this property of self lubrication. So functionality has to be improved, therefore post processing is required. Also sometimes we need to enhance the properties of the product which has been made by one of the processes which we have already seen in the previous slide, like powder metallurgy or infiltration or deposition process. So we convert the basic material into the final product by any of the processes which were outlined in the previous slide, and once the product is ready, it has to be post processed, and sometime for enhancing the properties we go for post processing of the product. And finally, in some cases we need to improve the quality, the aesthetics of the product, or we want to make the product pleasing to the eye. So in those cases, when we want to improve the aesthetics, sometimes we require the post processing. Now what are the important problem areas with the ceramic matrix composites? So one of the important limitation is they are brittle, they have high hardness, and these lead to certain processing difficulties. So sometimes we go for unconventional processing techniques. So we are going to cover in this module the processing techniques which are used for processing of ceramic matrix composites. So with this we come to the end of today's lecture. Just to review what we have covered today, we have just outlined the basic concept of the ceramics, we have just defined what are the ceramics, we have compared the ceramics or the properties of the ceramics with those of metals, we have tried to develop the concept of ceramic matrix composites based on the limitations of the ceramics. And then we have seen that what are the advantages or why we should go for ceramic matrix composites, and finally we have seen what are the important techniques which are used, or which are the important processing techniques which are used for processing of ceramic matrix composites, and finally we have seen that there are certain limitations on account of the properties of the ceramic matrix composites, and we have to overcome these limitations and we have to develop certain processing techniques which have rather been already developed, which we would be covering in our subsequent lectures in this module. So in our next lecture we would focus on the processing aspects of the ceramic matrix composites. Thank you.